Hi guys, what's up? Welcome back to all the sessions that we were having for the chemistry, and we were basically doing something related to classification of elements and the periodicity of properties. Okay, so having done the details about what actually the screening effect or the shielding effect, now I think it's a time that we should be moving on to the further discussion. So you remember in my last class I was telling you something related to how, because of the presence of inner lying electrons, the nucleus which is there in the center is not actually able to shield the outermost electron from the nucleus, right? So because these inner electrons are there, so the nucleus will not be able to apply its complete positive charge on the outside electron, right? So all these discussions regarding shielding effect or screening effect we were having in our last class. Now to begin up with the discussion once again, I think on the board you can see something related to Slater's rule which is written over here. This Slater's rule as such is not there for JEE syllabus also. So neither the Slater rules are there in CBSE, nor they are there in JEE, nor they are there in NEET. But the final answers that will be coming out of Slater's rule, they are really very important for all the competitive exams. So I'll be giving you a little detail of what are Slater rule. If you want to remember them, that's good enough, but if you do not want to remember them, you can just keep them aside. But this is important so that you should not say, oh, I don't know why this is happening. So you must be having an idea whatever I'll be saying because of screening or shielding, so you should be quite much there in confidence, right? So for that particular reason, today I'll be teaching you the a very brief detail about the Slater's rule, okay? But before we move on to Slater's rule, I need to tell you something regarding the s,p,d,f orbitals. Let us start our discussion once again with the screening effect or shielding effect. So discussing something about shielding effect, or the other thing that we were doing were screening effect. So what did I tell you in the last class? It was something like there is this nucleus which is there in the center and it is having lots of positive charges or protons, right? And now we do consider that there is an outermost electron which is lying somewhere here. So I told you if there were no inner lying electrons, then the nucleus would have completely attracted the outermost electron very efficiently. So there would have been a very cool interaction between the nucleus and the outermost electron, right? So now if I consider that case, the charge which is experienced by the electron would have been written as Z. Let's say the atomic number of nucleus, the atomic number of the atom that we will be considering is Z. So if the atomic number of the atom that we will be considering is Z, you can say that the positive charge on nucleus, the positive charge on nucleus will be Z times into charge on one electron, right? But then it has to be positive charge because the protons are having a charge which is equal but opposite in sign to that of the charge on electron. Am I right? So now can you say what is a charge experienced? So instead of saying what is a charge experienced, I should have written the charge that should be experienced by the outermost electron. So these two we have done. Now we were to find out the charge that should be experienced by the outermost electron. let us say that charge should be Z. Okay. Now see, because of the inner lying electrons, let's say, so 2 electrons were here, 1, 2, 3, 4 and so on, 8 electrons were there in the second shell, 6, 7, 8 electrons were there in the third shell, fourth and so on, so on, so on, right? So because of the inner lying electron, the outermost electron will now not be able to experience the complete charge of the nucleus, right? So let us now introduce a constant which is screening constant. So this screening constant is also known by the name as the shielding constant. So let us say I am just representing it by the symbol sigma. Okay, so what is sigma or what is shielding or screening constant? So it is the tendency, or you can say it is the potential so that the electrons can be screened from the positive charge of the nucleus, right? So this is the extent of shielding. Okay. Now, if the electron was supposed to experience a total charge of Z, but some charge is getting shielded. So, what is the effective charge that is experienced by the electron? So, we call it as effective charge experienced by the electron. So, the effective charge experienced by the electron will also be known as effective nuclear charge. So, the effective charge experienced by the outermost electron will be effective nuclear charge, and this can be written as Z effective. So, Z effective can be written as the actual charge on the nucleus minus sigma, which is screening constant. Okay, so finally we will end up the discussion here that Z effective will be Z minus sigma. Clear enough? For sure sigma will be greater than 1. So if the value of sigma will be greater than 1, then you can say the value of Z effective will be lesser than the value of Z. So the effective nuclear charge experienced by the outermost electron will be somewhat lesser compared to the nuclear charge on the nucleus itself. Okay. So now moving further, I will be telling you that this sigma value has been found to be different for that of S electrons, and it has been found to be different for P electrons, D electrons and F electrons. Okay. One another thing that I want you to remember very carefully is that if this is the nucleus, okay, and this I told you in the last class also, and the nucleus is quite small, fine, then the electrons which are lying close to the nucleus can form a very effective shield. So they will be having a very nice value of sigma. Okay. However, if the nucleus would have been bulky, okay, and now if I am trying to make a shield, then the electron density is not that much enough to shield the positive charge of the nucleus. So the sigma value of such electrons will be less. Okay, so this screening effect is basically helpful in the case of smaller atoms and not in the case of bulkier or larger atoms. Okay, now listen to me for one another minute. Okay. Now see, I am saying that we have done the electrons are there in orbitals. right? So what were orbitals? Then you know, right, that the orbitals are nothing but the three-dimensional space where the probability to find the electron is maximum. So three-dimensional space where the probability to find the electron is maximum. Right? So it is the three-dimensional space where the probability to find the electron has been found to be maximum. This is what is known as orbital. And from the discussion that we had in previous chapter in the atomic structure, we know that there are different kind of orbitals which are present. We have s orbital, which is basically spherical. Right? Then we have p orbital, we have d orbital and f orbital. So I told you this d actually stands for diffused. Right? So see, listen carefully. If I am talking about the electrons which belong to either s orbital or p orbital, then these electrons will have a very high electron density. Now what is electron density? Electron density is basically defined as number of electrons per unit volume in which the electrons are present. So if I am talking about the electron density of s and p orbitals, then the number of electrons in s is 2, number of electrons in p is 6, but the volume occupied by s and the volume occupied by p is very less. So they have a huge electron density compared to if I am thinking about d and f orbitals. Although I agree that d orbital has got a total of 10 electrons and f orbital has got a total of 14 electrons, right? So you should be saying, ma'am, they should be able to shield better. But I am saying they will not be able to shield better. Why? Because they are spreaded very far away. Fine. So there is a difference in the shielding capacity of s, p, d and f electrons as well. So not all the electrons will be able to shield equally. Some electrons will be shielding more nicely, some will not be able to shield nicely. Fine. Now see, one more thing I'll tell you in details. Let me just give you an idea. So you will be saying that, ma'am, when you are talking about s orbital electrons, you will say that, ma'am, s orbital has only 2 electrons, right? When I talk about p orbital electrons are 6. When I talk about d orbital, so they are 10. And when I talk about f orbital, f orbital electrons are 14, right? Now you might be thinking, this is the nucleus, this is the outermost electron, right? Now in this particular orbital, let us say there are 2 s electrons. So 2 electrons which are of s orbital. Right? Not like this, but s is having 2 electrons, right? This is how we should be writing. Now if I am talking about p, you will say, ma'am, there will be 6, then d will be having 10 and f will be having a total of 14 electrons, right? So our mind will say more will be the number of electrons which are present, more will be the shielding. That means since in f orbital, see, since in f orbital there are maximum number of electrons present, so they should be shielding the positive charge of the nucleus very well. If I'm talking about d orbital electrons, they are just 10 in number, so the shielding should also be less. After this, if I talk about p orbital, since they are only 6, so shielding will be even poor. And if I'm talking about the s orbital electrons, then there are just 2 s orbital electrons. So shielding has to be very, very, very poor, right? This is what we will think, because more will be the number of electrons lying in between the nucleus and the outermost electron, more will be the shielding, right? So this is what will be a layman knowledge, or this is what a layman will think, that if more will be the number of electrons, more will be the shielding, right? But guys, this is not gonna be the case. The case is little different. Now I'll tell you how we will define our case. Let's consider that there is a concert going on and this is Arijit Singh. Okay, and he is singing some very, very good song and so many people are there. So it's crowd. So I am standing here, okay. I dressed in blue and so many people are there. Now, every one of us, when Arijit Singh is there, so every one of us would love to go to him, right? But then it is very obvious, no, there will be bouncers for sure. They'll not allow us to go and shake our hands with Arijit Singh, right? So there will be bouncers standing. Now tell me which is a better option. So Arijit Singh has hired 2 bouncers. And both of them are like khali. So they have a good build. So will this situation be okay, that they will be able to shield Arijit Singh from all of us approaching towards him? So this is case number 1. Only 2 bouncers. But they are like this. Okay. So this is one case. Or tell me, if I do not consider this case, I am considering 6 people who are standing and these people are even more slim compared to me. So do you think these will be okay? Okay, so these are, second option is we have 6 bouncers, but they are very thin and weak. Okay, considering the third case, you have 10 bouncers, but you know these 10 bouncers are who? These are small 3-3-3-year-old kid. Okay, so they are 10 in number, but then there are 10 bouncers who are 3-year-old kid. Okay, or tell me the fourth case, that we have 14 but all are newly born babies. So see, I can't even see them. So these are newly born babies. So these are the fourth option. 14 bouncers will be there. So if you are talking about who are they, all of them are bouncers. But these are newly born. Now you tell me which case is better. These 2 are enough, or we need 6, but then they are even more weak compared to me, or 3-year-old kid we need, but 10 we have to take, or let's go to another option, 14 bouncers are there, but all of them are newly born babies, very cute babies. Genuinely you will say, ma'am, take only 2, but take them actual bouncers, right? They have to be bouncers. Don't take them, don't take like yourself, someone will come and slap me and then they'll go to meet Arijit, right? Don't take 3-year-old kid, don't take a newly born baby, right? You need to take bouncers who are actually the bouncers. Clear, no? Now let me try to correlate the same thing with the help of an atom. So instead of Arijit Singh, now we have a nucleus which is having so many positive charges or protons. Okay? Instead of these many people who are like me, we just have electrons, 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 electrons. So many electrons are there who are revolving around the nucleus, and let us say this is the outermost electron. So let's say I am standing here. Now you tell me, So these all are inwards lying electrons. So all these electrons are lying in the inner shells. So these are the electrons in one shell, electron, other shell, and so on. Okay, and this is the outermost electron. So this is me who wants to go to meet Arijit Singh, who is here, right? Now tell me, should I be taking just 2s electrons because I know they are very much bulky. Bulky means they have a huge density. Huge density means although there are only 2s electrons, but they are present in so smaller a volume that they are making a huge good cloud around the nucleus. So they will be able to shield the nucleus like these two bouncers who are only 2 in number, but then who are these huge, right? If I am not talking about s electrons, let me now come on to p electrons. So others will be p electrons. Although you have taken 6 p electrons, I totally agree with you that you have taken more number of electrons. But yaar, these are so poor. They are even thin, they are even weak compared to me. And I have to go to meet Arijit Singh and see so many weak people are there. I'll just come, slap them. Come, slap, come, slap, and I'll meet him. Right? So they won't be able to hide me. They won't be able to hide Arijit Singh so that I can't go and touch him. Right? So that is also wrong. Now let us say not 6, although I have taken 10 electrons. You know, right, D and F electrons are so damn diffused. They are present all around the nucleus, but then there is huge space between these two d electrons. So see, I can say if nucleus is here and 2 bouncers are standing here, or let us say they are 6 but then they are standing far away. So the distance between bouncers is increasing, right? And when the distance between the bouncers are increasing, I can easily come. Look at D. One D is here, other D is here. I can easily come, man. Who is asking me to go that side or this side? I'll easily come to this side. Right? So it doesn't matter how many number of electrons you are considering. Although S will be having only 2 electrons, P has more, 6, D has even more, F has even more. But the shielding which is done by s orbital electrons is best compared to the one with p, compared to the one with d, and compared to the one with f orbitals. Okay, and hence this finally gives me the screening power, and the screening power or the shielding power of all the electrons can be written as, so the shielding which is given by s orbital electron will be better than that of p, d and f. Okay, so this is the screening power or shielding power. So s electrons will be able to shield best, then p, then d and then f. And just after some time you will understand that these D and F electrons are so damn diffused that they are poor shielders. They will not be able to shield the outermost electron from the positive charge of the nucleus. Okay, and that is why we can say the sigma value that you have done will be different for S, P, D and F electrons. Okay. So there was this, so this was all about the qualitative discussion that we were having. So there was this person, Slater, and he gave the rule to determine the value of sigma by his rule as Slater's rule. So Slater's rule is basically used to find the value of Z effective, so effective nuclear charge which is experienced by the outermost electron on, so the effective nuclear charge experienced by the outermost electron because of the nucleus can be written as Z minus sigma, where sigma is the screening constant or the shielding constant. Okay. Now I am going to draw a table for you. So with the help of this table, you will be able to understand how to find out the Z effective for different kind of electrons. Listen to me. So let us say this is the nucleus. Let's consider like this. So any of the outermost valence orbit will be known as nth orbit. This will be n minus 1th orbit, n minus 2nd orbit, n minus 3rd orbit, and so on, so on, so on. So there will be different orbits that you can draw as nth, n minus 1th, n minus 2, n minus 3, and so on. Okay. Now listen. Let me just show you the values with the help of a table. So let us consider so this is for nth electron, this is for n minus 1th electron, this is for n minus 2, n minus 3, and so on. Okay, so these are the values that I'll be writing. So this represents the s or p orbital. If the electron belongs to s or p orbital, then these are the value of sigma that you will be writing. And this box will represent if the electron belongs to d or f orbital. Okay. If it is nth electron and it is belonging to s or p orbital, the sigma value will be 0.35. If it is n minus 1th electron but belonging to s and p orbital, the sigma value will be 0.85. If, however, it is n minus 2, n minus 3, n minus 4, n minus 5, n minus 6, any electron, but it is belonging to s and p orbital, the value will be taken as 1.0. Okay. Similarly, if it is nth electron of d and f orbital, the value will be same 0.35. If it is n minus 1th electron of d and f orbital, the value will not be 0.85 but 1. Similarly, if the electron belongs to n minus 2nd or n minus 3rd orbital, but it is d and f orbital, again the value will be taken as 1.0. Okay. So once again, listen to this complete thing here. So let me divide it into two parts. Just imagine as if this part is considered to be, so let me write it here as well. So I am considering the atom to be divided into two sections. So that is just for remembrance. Okay. So let us say this is again nth orbit, n minus 1th orbit, then we have n minus 2nd orbit, n minus 3rd orbit, and so on. Okay. So to the bottom side, this is represented as s and p, and there I am representing them as d and f. Okay. Now see, if it is nth, the value will be 0.35. If it is n minus 1th, 0.85 per electron. If it is n minus 2, 1. Anything inside, 1. Okay. Similarly, let us say if the outermost electron is d and f electron. So for nth, it will be 0.35. For n minus 1th, it will be 1.0. N minus 2nd, 1.0. N minus 3rd, 1.0, and so on, so on, so on. Okay. So this is all about Slater's rule. I am sure you would not have understood much with the Slater's rule because we didn't do any question. But before I proceed on to the question, I want you to note it down very carefully, note down each and everything in detail so that now we can proceed on to the question answers. Note it. Okay guys, so I think you would have written down everything. I am not erasing the table here, but I will be erasing this part. Now let us do certain questions. So with the help of the questions, you will be able to understand the Slater's rule even more perfectly. Okay. So let's try some of the questions on the basis of this particular table. So the very first question is, you need to find out the Z effective for the outermost electron of lithium. Outermost electron of lithium. Now I'll tell you the rules also, and I'll tell you how to find out the Z effective. So point number 1, you need to write the atomic number of lithium, which is 3. Then point number 2, I want you to write down the electronic configuration, which is 1s2 2s1. Okay. So see carefully. Now segregate. So the nth orbit, I want you to segregate it, and n minus 1th orbit segregated. So I could have written it 1s2, this is one orbit, and another is 2s1, the other orbit. Okay. Now see, this is the nth orbit, and this is the n minus 1th orbit, right? Now see, we need to find the Z effective for the outermost electron of lithium. So this is the outermost electron. And if this is the outermost electron, that means this will not be utilized in shielding. So this will not be shielding itself. The inner lying electrons will shield. So this is the nucleus here. These inner lying electrons are going to shield the outermost electron from the positive charge of nucleus, right? So we are not going to consider anything here. Okay. Now see, how many electrons are there? 2 electrons. So what will be the value of sigma? Sigma is equal to, and this is an s orbital electron. So see, come here, the n minus 1th. So we are not going to consider the nth. No, we need to consider n minus 1th electron, and that too belonging to s orbital. So the value will be 0.85. So do here. So we'll say 2 into 0.85 will give you 1.7. Now I have seen so many students, they'll say, ma'am, Z effective is 1.7. Wait, this is just screening constant, which is sigma. The Z effective was basically defined as Z minus sigma, which is 3 minus 1.7. So 1.3 is the effective nuclear charge experienced by the outermost electron of lithium. See, once again, lithium was something like this, having 3 units of positive charge. First orbit, second orbit. This is the outermost electron, 2s1, right? If there would have been no inside lying electrons, then how much it would have faced? It would have faced a total charge of 3 units of positive, right? However, I am saying because of the inner lying electrons, one is lying here, other is lying here. So this nucleus is now not able to provide its complete positive charge to the outermost electron. So when the nucleus is not able to provide complete positive charge to the outermost electron, how much these two are shielding? This will shield 0.85, this will provide a shielding 0.85, making it a total of 3 minus 2 into 0.85. So which is 3 minus 1.7, and the answer is 1.3. Okay, so now this outermost electron feels as if the nucleus is attracting me with a charge just of plus 1.3 units and not 3 units. Fine enough? So this was how you could do the use of Slater's rule to find the effective nuclear charge. Let's do for one another element, which is, now we need to find the Z effective for the p electron of boron. So we need to find, this is our second question. Z effective for the outermost electron of boron. So Z effective for the outermost electron of boron. How to consider? First write the atomic number of boron, which is 5. So write down the electronic configuration: 1s2, 2s2, 2p1. Okay. Segregate S and P. Also segregate according to the orbit. So let us see. 1s overall is having 2, 1 orbit. 2s and 2p belongs to second orbit. So 2s to 2p, 1. Like this you have to do the segregation first of all. Now what you need to do? You need to find the Z effective for this outermost 2p electron. Right? But then this, so okay, write one more thing. This is n minus 1th and the whole are nth electrons. Right? You need to find what is the effective nuclear charge experienced by this 2p1 electron. So this electron will not itself shield. So if I am going to meet Arijit Singh, why will I shield myself from Arijit Singh? The other people who are standing there will shield me, right? So not I will not be responsible for shielding. So just ignore the 2p. Fine. Now let us try to calculate the value of sigma. So sigma value will be 2 into, so 2s, 2 were there, into nth, and this belongs to s orbital. So consider nth electrons belonging to s orbital will contribute 0.35. Okay. So we'll write 2 into 0.35 plus, let me write it below. So sigma will be 2 into 0.35 plus, how many others are there? 1s, 2. So 2 electrons are there to be multiplied. Again they are n minus 1th orbit and s electron. So see, n minus 1th orbit s electron will contribute 0.85. So once I am saying they will contribute 0.85. You solve this thing and the answer comes out to be 2.4. Okay. But don't again say that, ma'am, this is effective nuclear charge. No guys, the effective nuclear charge is written as Z minus sigma. What is the value of Z? The value of Z is something like 5, no? Minus sigma is 2.4 and the answer comes out to be 2.6. Fine enough? That's see once again. So if boron is there and you feel that, ma'am, the outermost electron of boron should experience a positive nuclear charge of how many units? 5 units. Because 5 protons are there in the nucleus of boron. But now what I am saying? I am saying no yaar. So there are 4 which are lying inside. So they will be shielding the positive charge of boron from the outermost electron. So now this outermost electron, instead of experiencing a charge of plus 5 unit, it will experience a charge of just 2.6 units, which you can see is just almost half of it. So this problem, or let us say this particular effect, which is shielding effect or screening effect, is actually responsible and will tell us so many deviations thing. So whatever we say, no, that this is the deviation, this was expected, but this we got as a result. So all these things will be able to tell or conclude finally on the basis of this shielding effect or Slater's rule. Guys, now listen carefully. We have done this particular section. So S and P we did, this we did, this we did. So we are left with 1, 2, 3, 4 and these 5 sections, right? But that is a complete another 15-20 minutes lecture. So I will not be continuing it today because I know it will be difficult for you to catch on. So let's do one thing. In the next class, we'll continue with the Slater's rule itself, but then we'll take the examples of D and F orbital electrons. We'll do 2 or 3 more examples so that with the help of this, you will be actually able to understand what is Slater's rule. And once we'll be able to discuss the entire information about Slater's rule, we will be able to get the results that we'll be getting because of screening effect or shielding effect. Okay? But for all those things, you need to wait for the lecture. And before waiting for the lecture, I want you to revise it. Revise it, don't mug it up. Even if you do not want to practice, don't practice, but just understand it from the crux. Okay? So that's it for today. Take care and we'll be meeting again. Bye-bye.